Hello and welcome to this presentation. Today I'd like to show you how we can combine graphical and texture model editing. We use this Ecore diagram editor and this small Ecore meter model as examples. Both graphical and texture model editing have their advantages and disadvantages based on the modeling task. When, for example, I like to draw a generalization arrow, this is best done graphically since I have to draw a line between two boxes. Adding an attribute, on the other hand, can be very annoying when done graphically because you have to click the attribute, you have to name the attribute, select the attribute, go down to the property view to find the eType field and enter a type for the attribute. So this is a task better done textually. I can simply select the class, go into the context menu and open a texture model editor for this class. This editor pops up in an overlay window and shows me a textual representation for the class. And now I can go ahead and simply add a signature for this operation. And I have all the features that I'm used to, like code completion, error annotations, or things like syntax highlighting. When I commit my changes here, the change also appears in the graphical view. And from now on, I don't even need this property view anymore, and I simply close it. The advantage of texture model editing becomes even more obvious when we try to add an operation to this class. Since operations usually have parameters and lots of typing information, this costs you lots and lots of clicks when you do it graphically. But doing it textually simply is writing down the signature and you are done. Of course, I can also use texture model editing to manipulate the graphical parts of a model. Removing this extend clause, for example, will also cause the arrow to vanish. When I now try to put the arrow back in again, I actually show a disadvantage of texture model editing, because this adding of the arrow causes the arrow to be auto layouted and I have to manually layout it later. So this task is better done graphically. The whole idea behind this integration of textual and graphical model editing is to give you the choice to select the appropriate method for the appropriate modeling tasks. So how is this integration done technically? First of all, the editor that we see here is a normal GMF generated graphical editor. And we use Eclipse object contributions on top of these editors to provide the open texture editor action for all EMF objects. So no matter what EMF object you are selecting, you will get this action. And when I open this editor on a class, I get a representation for the class. When I open this editor on an association end, I simply get the textual representation of this association end. When I select an operation, the same thing. Actually, through this whole object contribution stuff, the embedded texture editor does not even know what the host editor is. The embedded texture editor simply gets handed the EMF object, and via this EMF object it navigates to the editing domain of the graphical host editor. And within this graphical host editor's editing domain, the texture model editor can do all the changes to the model within the graphical model editor. And this is all possible without touching the implementation of the host editor, without even knowing what the host editor is and how it is implemented. This means that when I open the tree-based Ecore editor instead of the diagram editor, I get the same picture. Here again we have EMF objects, and of course we have the object contribution. And I can also open the texture model editor in this tree editor. And I can also change the model within this tree editor. So removing the name attribute, and the name attribute is also gone here in the tree editor. What the embedded texture model editor does is simply encapsulating all the changes that I make here within this editor, and all the changes are encapsulated into a single EMF command that is executed within the host editor in the very moment I commit the model change. So Through this encapsulating whole textual model editing sessions into single commands, I integrate the under-redo facilities of both editors with each other. So I can go into the under-redo of this editor and simply undo the changes that I've done with the textual editor. So I get the name attribute back, and I also get the renaming of the operation back. So to conclude, I do not care what the host editor is. I don't have to know the implementation of the host editor. I don't have to change the host editor. The embedded texture editor are simply provided via object contributions to all EMF objects. And this, of course, is not only working for Ecore editors and Ecore model elements, but for all EMF models. In the same way, the graphical editor is generated from notation description based on the GMF framework. We simply use our textual editing framework to provide these text editors, and for each meta model we provide a syntax. In the case of the Ecore model, the syntax looks something like this here. So this simply says I am a syntax for the Ecore meta model, and then this is a grammar-like presentation of the textual notation that we use. So if you look at class, for example, each class is starting with a proper indentation, then a possible switch for making the class abstract, making it an interface. Then comes the keyword class, a space, the name of the class, a space, the super clauses, then the block goes open, and we have the class contents, which can be an attribute and reference on operation or whatever. So the whole thing is generated. It can be generated for all kinds of meta models, and it can simply be integrated with graphical editors that you build, or the simple generated tree editors that EMF provides automatically. So thank you for listening to this presentation, and if you want to learn more about our textual editing framework TEF and this whole integration of graphic and textual editors, just visit our websites and have fun.